Here we see one sequence, that is sequence A, which is consists of the terms 1, 6, 11, 16. What is the value of 100 term of this sequence? Again, see another sequence, that is sequence B, which is consist of the terms 5, 13, 25, 14, and so on. So what is the value of 55th term of this sequence? In this video, we are going to learn how to find the general term or nth term of these two type of sequence. With the help of that general term or nth term, we can easily find the 100th term and 55th term of this sequence. With the help of that general term or nth term, we can easily find any term of any sequence. Welcome to this video, which is about finding nth term using the difference formula. Let's start the detailed discussion. Look carefully the sequence A, that is 1, 6, 11, 16, and so on. Look carefully this sequence and try to identify the pattern of this sequence, that is how this sequence is formed. For this, first we take the difference between the second term and the first term. Here the difference is 5. Similarly, the difference between third term and the second term, which is also 5, and the difference between fourth term and the third term, which is also 5. This difference is called the first difference. In this case, that is for this sequence A, the first difference are equal. So we can say the difference between the next term and the previous term is always 5. That is, the difference between two consecutive terms is always 5. If the first difference of any sequence are equal, that sequence are called the linear sequence. In this case, the sequence A is a linear sequence because here the first difference are equal. For the sequence A, so we can get the next term by adding 5 with previous term. With the help of this adding process, we can find the 100th term, but this process is time consuming. How can we easily find the value of 100th term for this type of sequence? If we can find the general term, that is n term of this sequence, and substitute the value of n equal to 100 in that term, then we can easily get the value of 100th term. This process is very easy, and for this process we need less time. Now we are looking for how can we find the nth term. Here the finding formula of nth term of linear sequence, that is first term plus n minus 1 into difference. In this case, this difference is first difference. Here the first term is the first term of this sequence and difference is the common difference, or we can say first difference, that is difference between two consecutive terms. So for the sequence A, the first term is 1 and the common difference, that is first difference, is 5. So if we substitute the value of first term and the difference in the formula, then we get the nth term, that is 1 plus n minus 1 into 5. Here the first term value is 1 and the difference value is 5. After simplification, we can get the value, that is 5n minus 4. This is our nth term or general term for this sequence A, which is linear sequence. Now we can easily find the 100th term and as well as any term of this sequence. If n equal to 100, then we get from this 5n minus 4, that is 5 into 100 minus 4, which is equal to 496. This is our 100th term for this sequence A. This process is applicable for any type of linear sequence. So if the first difference of any sequence are equal, then we can easily apply this formula to find the nth term of that sequence, and after finding the nth term, we can easily find any term of that sequence. Now look carefully the sequence B, 5, 13, 25 and 41 and so on. How this sequence is formed, or we are looking for the pattern of this sequence. As previous, that is similar to the sequence A, first we find the difference between the two consecutive terms, that is second term and the first term, which is 8, and third term and second term, which is 12, and fourth term and third term, which is 16. These terms are called the first difference. For the sequence A, this term was equal, but here for sequence B, these first difference are not equal. Let's take the difference between these two terms, that is 12 and 8, which is equal to 4, and the 16 and 12, which is again 4. Now we can easily see that these differences are equal, which are called the second difference. So for this sequence B, the second difference are equal. If the second difference of any sequence are equal, that sequence is called quadratic sequence. So we can call this sequence B as a quadratic sequence. The previous sequence was linear sequence. We learned the formula for finding nth term of that sequence. Now we are going to learn the nth term of this quadratic type sequence, that is sequence B, where the second difference are equal. So how can we find the nth term of this quadratic sequence? A quadratic number sequence has n term, which is equal to an square plus bn plus c. That is, for every quadratic sequence, we get n term look like this term. That is an square plus bn plus c. We are looking for the value of a, b and c. If we get the value of a, b and c, after substituting the value of a, b and c, we can easily get the general term or nth term of that quadratic sequence. The steps for the finding the value of a, b and c. Step 1, a equal to the second difference divided by 2. With this formula we easily get the value of a. That is, from the sequence we get the second difference and the second difference divided by 2, which gives the value for a. Now step 2, substitute n equal to 1, 2, 3 in an square. After getting the value of a, we put the value of a here. Then substitute the value of n equal to 1, 2, 3 in that an square. Step 3, subtract the value of an square from the corresponding original terms of sequence. That is, if we substitute the value of 1 equal to an square, we get one term. That will be our first term. If we substitute the value of n equal to 2, we will get the second term. In this way, if we substitute n equal to 3, we get third term. And in step 3, we subtract this first term from the original first term, and the second term from the original second term, and third term from the original third term. And step 4, find the nth term of the difference generating from step 3 using the previous formula used for sequence A, that is the linear sequence nth term formula, to get the value of B and C. From this step 3, we get some difference, which is the difference between the corresponding term of this an square and the original sequence. That is the first term of this an square and the first term of the sequence. With this difference, if we form another sequence using the linear sequence nth term formula, we have to find the nth term of that sequence, which we get from this step 3. After getting this nth term, we can easily get the value of B and C. If we see one example, that will clear the whole process. Let's find the nth term for the sequence B. Step 1, a equal to 4 divided by 2, which is equal to 2. We get the second difference for the sequence B, which was 4. So 4 divided by 2, which is equal to 2. So we get the value of a, which is equal to 2. Now step 2, substitute the value n equal to 1, 2, 3 in 2n squared. That is, with this 2, a equal to 2, if we substitute the value of a, that case we get 2n squared. Now we are going to substitute the value of n equal to 1, 2, 3 in this 2n squared. If n equal to 1, then 2n squared equal to 2. If n equal to 2, then 2n square equal to 8. And if n equal to 3, then 2n square equal to 18. After substituting the value of n equal to 1, 2, 3 in 2n square, we get the new terms, that is 2, 8 and 18. Now let's go to step 3. 5, 13, 25. This is our original sequence, that is sequence B. Now write the new terms here, that is 2, 8, 18. That is the sequence we get from this difference. That is the sequence when we substitute the value of n equal to 1, 2, 3 in 2n square. Now, according to the formula, we have to subtract this one. That is 5 minus 2, which gives 3, 13 minus 8, which gives 5, and 25 minus 18, which gives 7. So, we get here one new sequence, that is 3, 5, and 7. Let's go to step number 4. In step number 4, we have to find the n term of this sequence, which we get from the difference, that is 3, 5, and 7. This one we get from the step 3. So we are going to find the n term of this sequence. If we look carefully this sequence, the difference between first two term is 2 and the second and third term is also 2. So for this sequence, the first difference are equal. That's why we can easily call this sequence is a linear sequence. And we know how to find the n term of the linear sequence. Using the formula of finding n term of linear sequence, we can easily find the n term for this sequence. Here the first term is 3 and difference is 2. That is the common difference, or we can call the first difference. So the n term is 3 plus n minus 1 into 2. After simplification, we get the value 2n plus 1. This is the n term of this sequence. Now compare with bn plus c, we get b equal to 2 and c equal to 1. That is bn plus c. If we compare these two terms, then we get b equal to 2 and c equal to 1. Now we have the value of a, b and c. Substitute the value of a equal to 2, b equal to 2 and c equal to 1 in an square plus bn plus c, which is the n term of quadratic sequence. We get the n term 2n square plus 2n plus 1, which is our n term for sequence B, that is quadratic type sequence. Now we can easily find the 55th term of this sequence B. We get the n term, that is 2n square plus 2n plus 1. If n equal to 55, then 2n square plus 2n plus 1. If we substitute the value of n equal to 55 here, then we can easily get the value, that is 6161, which is our 55th term of the sequence B. Using this 4 step, you can easily find the n term of any quadratic type sequence. After finding the n term, we can easily find any term of that sequence.